Hi, this is Professor Carter. This is the fourth video on the neoclassical theory of production and distribution. We saw in the last video, the third video, we developed the production surface. It's not a utility surface, it's a production surface. Okay, so be clear about that. Okay, we saw that the production surface is going to be a production surface for a well-behaved production function. A well-behaved production function is going to be a production function that exhibits diminishing marginal productivities with the factor inputs. We saw that this results in a production surface that has these properties such that we have different techniques in production that are going to produce the same quantity of output. So the production function is going to be the technology. And technology you can think of as that three-dimensional surface. And then within the technology, there are going to be different techniques. Techniques are going to be defined as combinations between capital and labor. So you're going to have different techniques, which at different, when we scale it up, allow for the production of the output according to this well-behaved a neoclassical diminishing marginal productivity production function, right? And that's going to be the nature of the matter. Now, that we are going to be assuming, because it's from this is the assumption that's being made about the behavior of the producer, right? We're looking here at producer equilibrium, so this is the assumptions that are going to be made about the producer, because we're going to use this in order to arrive at our isoquants and in order to arrive at our producer equilibrium, etc. So we define, by the way, this idea of the isoquant. We define the isoquant here as the locus of different combinations of capital and labor. That is to say, the locus of the different techniques of production that yield the same quantity of output. Here we say that the alpha technique, which is relatively capital intensive, relatively more capital, relatively less labor, results in the same quantity of output as the beta technique, which is a relatively labor intensive technique, relatively less quantity of capital, relatively more quantity of labor. This means that in order to produce the same output, if we give up capital, we've got to increase our labor, right? And so that then allows us to arrive at the slice out of the production surface, and that slice out of the production surface is referred to as the isoquant. All right, iso meaning the same, quant, which is quantity, so it's going to be the same quantity across the different techniques of production. It's the production surface dual of what in consumer theory is referred to as the indifference curve. If this is a utility function, capital and labor would be good X and good Y, and you wouldn't have an isoquant, you'd have an indifference curve, right? Really essentially the same thing. Okay, it is the same thing actually, just a little bit of a twist on the production side, a story, et cetera, right? Now from there, you're going to take the top down of this thing. Okay, the top down is going to be referred to as commodity space. All right, so we're going to define this thing commodity space. Now, whenever I use the word space, I'm about to draw a two-dimensional graph. When I say the word surface is going to be a three-dimensional graph. We're not going to be doing too many more surfaces in this course, but when we do, it'll be a three-dimensional graph. Space, however, we're going to have a lot of. Space is going to be the labeling of the axes, okay? This is not commodity space. There, I did it again as consumer theory. This is factor space, all right? Physical factor space, okay? That's a mistake there, okay? So the physical factor space is going to be simply this, all right? The factor space is going to be on the axes. We're going to have the two different quantities of our factor input. It's going to be the top-down view of our production surface. All right, so that's going to be the quantity of labor. That's going to be the quantity of capital. All right, so this is going to be the capital input here. This is going to be the labor input here. Okay, we're going to say that we have a nice diminishing marginal product of labor production function, which means then that, let me do it right, I have it in red. Okay, we have the isoquant, which is going to be here. Okay, so you're looking top down on this. Okay, this becomes your isoquants. All right, isoquants. All right, which means that this output along here is going to be the same. Okay, and then you're going to have the different techniques of production. Okay, this is going to be the alpha technique. Okay, in the alpha technique, you have relatively more capital and relatively less labor. All right, so it's going to be the capital intensive technique. All right, so you're going to have relatively more capital and relatively less labor. This is going to be capital alpha. This is going to be labor alpha. And then you're going to have the beta technique. Okay, beta technique is going to have relatively less capital and relatively more labor to produce the same quantity of output, right? Because we see that the output y beta is equal to the output y alpha. So it's going to be the capital and labor inputs for the two respectively. Now what we're going to be considering, we're going to go back to that question of the marginal rate of technical substitution. And when we're looking at the question of the marginal rate of technical substitution, what we're going to be doing is we're going to be moving down the isoquant, right? We're going to be moving down the isoquant here. I was looking for this. Okay, here. So we're going to move down your isoquant. All right, as you move from the alpha technique to the beta technique, and when you do that, okay, you're going to then have to stay. We're going to force the equality that there's going to be, you're going to be on that same quantity of output being produced. You're going to be along that isoquant. You're going to have a negative quantity of capital given up in exchange for a positive quantity of labor received such that the output produced is exactly the same. And that's the definition of the marginal rate of technical substitution capital for labor. It's going to be equal to the negative quantity of capital divided by the positive quantity of labor such that the output is constant. Okay, it's going to be a movement along the isoquant. All right, so we say here it's a movement along the isoquant. All right, isoquant. And when you have a movement along the isoquant, we come back to our production function and we look at our total differential. Okay, remember the production function is going to be this. All right, y is equal to a function of the capital input and the labor input. So if we're going to take the total differential that we would have here, the quantity of capital, the change in the quantity of capital, times the partial derivative of quantity of output divided by the partial derivative of the quantity of capital, plus the total change in the quantity of labor, divide that by the partial derivative. Okay, or you're going to set that equal to the change in the output along the indifference curve, which you set equal to 0. That's going to be the whole point. Okay, this is going to be no change along the indifference curve, along the indifference curve, isoquant. All right, isoquant. All right, which means then when you solve for this, okay, so remember your marginal rate of technical substitution is going to be the quantity of capital given up in exchange for labor received such that we remain on the same isoquant, produce the same output. That's going to be negative delta K over positive delta L. When you solve for this, you get negative delta K over positive delta L. When you rearrange that, you get the marginal product of, or the partial derivative of output with respect to labor, divide that by the partial derivative of the output with respect to capital. Here you can demonstrate that the marginal product of labor divided by the marginal product of capital is equal to the marginal rate of technical substitution, which is going to be the movement along an isoquant here. This is going to be the slope of the isoquant. Slope of the isoquant. And since this is a well-behaved production function, it's going to actually be convex to the origin. This is what's meant when we have convex technologies. Okay, you're going to have there. I'm almost done here. Okay, and so then you're going to be moving then into the idea of the different technologies. Okay, which is going to be here. This is going to be the quantity of capital. Okay, this is going to be the quantity of labor. Okay, this is going to be the isoquant. All right, which is going to be, well, do it in red. Okay, the isoquant, which is going to be here. Okay, we're going to have the different the different technologies. Okay, it's going to be a different technique. The technology is the same. These are different techniques within the technology. Going to have the alpha technology is going to be the capital intensive technology. So what we do here is we take the ray from the origin. Okay, we're going to take the ray from the origin, and we're going to move through the alpha input of the alpha technique. Rather, that's going to be the capital labor ratio for technique alpha. This is going to be capital over labor for technique alpha. This is going to be the capital labor ratio for technique beta. Okay, this is going to be capital labor, capital is K, lowercase k for technique beta is equal to K over L for technique beta. This is going to be, the alpha technique is going to be the capital intensive technique, capital intensive technique of production. All right, technique, which is going to be here. And the beta technology or technique is going to be the labor intensive technique. Labor intensive technique. All right, and so then we have the capital and labor intensive techniques there, and they're going to be, of course, why do we have the choice of technique? And then the last thing I'll do, or to end this and get it under 12 minutes here, is going to be the isoquant is going to show more output as you move to the northeastern corner. All right, you're going to have your isoquants here. I should have put it in red, but you get it. Okay, so this is going to be more output as you move up this way. All right, so you would say here more output. All right, that then becomes the production surface, and then you put it in factor space. You consider the different techniques of production, and then you look at it with respect to the marginal rate of technical substitution. And this is going to be the production side of the producer equilibrium. The next lesson we're going to be looking at, we're going to be introducing the cost side, which is the money relation. Okay.